I never thought as a physician I would actually see the cure to cancer, the end of cancer. The moment that a single blood vessel touches a tiny microscopic tumor, it will grow 16,000 times in size in just 2 weeks. We pull our hair out trying to figure out, like, what's going on? How do we make people do better? Well, it turns out that a 1 centimeter breast cancer already has 1 billion cancer cells that have already multiplied. That microscopic cancer multiplied 1 billion times. That's the smallest one you can feel. The groups of responders, people who did well versus people who didn't do well for immunotherapy, except for one thing. That one thing was one bacteria, Akkermansia muciniphila. Well, it turns out that there are certain foods you can eat that grow Akkermansia. What are those foods? And what they found is that women who had excess body fat over the period of 13 years had a 3-fold increase in the risk of developing breast cancer. So with this kind of knowledge, what can we do with cancer? Not just breast cancers, but in general. Number one, I never thought as a physician I would actually see the cure to cancer, the end of cancer. But actually, I have to tell you, I have now seen where the end of cancer is coming from. I've seen how the war is going to finish because I've had well over a dozen patients, and there are hundreds of people like this that are starting to form that can go from stage 4 cancer, that's game over cancer, to stage 0. We can do this. And not for everybody yet, but we're beginning to see where the light at the end of the tunnel is, and it involves your immune system. And some of the remarkable scientific breakthroughs are teaching us that our body heals itself against diseases as serious as cancer in ways that the pharmaceutical industry can't by itself do. But it really relies on the body. So when you talk about food as medicine or medicine as medicine, none of them are as powerful as what the body is hardwired to do by itself. In 100 people who were receiving immunotherapy for different types of cancer, that if you looked at the difference between people who responded, lived, did well, versus people who didn't respond, didn't do well, died. All right, and that's the frustration with the types of treatments my mom had. Some people do well, some people don't do well. We pull our hair out trying to figure out, like, what's going on? How do we make people do better? Well, it turns out that when you compare everything, gender, age, comorbidities, all the other genetic factors, the research that was presented showed that there was no differences between the groups of responders, people who did well versus people who didn't do well for immunotherapy, except for one thing. That one thing was one bacteria. The responders had one bacteria called Akkermansia muciniphila. So most bacteria have a genus and species, first name, last name. First name is Akkermansia, last name is muciniphila. Okay, it likes to grow in mucus, muciniphila. Where is there a lot of mucus? In the colon. Where's the colon? That's on this model, the blue area. So Akkermansia grows right here in the cecum, which is the pouch in the colon right at the beginning before you take the up elevator to the top of the colon. That's where it grows. If the people had that Akkermansia, they would respond to immunotherapy. So what the researcher did, she took out the Akkermansia and brought it to her lab of the responders from humans and gave it to mice who were not responding to immunotherapy. Boom. She'd resurrect the immune response to kill the cancer. So this is one of the first bacteria, and there may be many, many that we haven't yet discovered. All right, so like my whole career has all been about discovery. There may be more bacteria, but we discovered at least one, the presence of which seems to be absolutely vital. If you are a patient receiving immunotherapy, the type of immunotherapy called checkpoint inhibitors, if you want to tip the odds in your own favor of being a responder. Now, how do you get Akkermansia? Well, at the time, there was no Akkermansia probiotics. Now you can actually find Akkermansia probiotics. But at the time this was coming out, you had to grow your own Akkermansia, DIY Akkermansia. All right. So how do you grow it? Well, it turns out that there are certain foods you can eat that grow Akkermansia. What are those foods? Pomegranate juice, pomegranate seeds will grow Akkermansia. Cranberries, Cranberry juice, dried cranberries will grow akkermansia. Concord grape juice or Concord grapes will grow akkermansia. Chili peppers will actually grow akkermansia. Chinese black vinegar. You ever go to dim sum and have soup dumplings?
Oh, yeah.
The black vinegar sauce that they use for as a condiment to the soup dumplings? Chinese black vinegar. That will prompt your body to grow akkermansia as well. Every day, every 24 hours, there are 10,000 mistakes that are made in your body that your body doesn't catch, that propagate in the document of our body as it goes on. 10,000. Each of those is a microscopic cancer. A microscopic cancer is just that. It's microscopic. It's too small to be seen with the naked eye, but it's abnormal, and that thing could turn into a big tumor that could eventually kill you. So why don't we die from cancer all the time? Now, this is actually something that I see as a physician. I have a patient diagnosed with cancer. They always ask me, Dr. Lee, why me? Why did I get breast cancer, colon cancer, pancreatic cancer, brain tumor? A very, very natural question, and I do my best to try to provide an empathic answer to that question. But as a researcher, I have a more interesting question. Given the number of mutations that occur in our body every single day, why don't we get cancer more often? Why don't we all get cancer as kids? Cancer can happen in children, but not as often as we have mutations. And it turns out this was the great unlock for me in terms of health. The reason that we don't become more sick from all kinds of diseases, including cancer, is because our body is hardwired with its own health defense systems, so that we've got these swashbuckling defenses that are firing on all cylinders all day long. From the moment we're born until our very last breath, these systems that are inside our body defend our health, including the microscopic cancers, spots them, takes them out, kind of like a police cruiser patrolling a quiet neighborhood, sees a drug dealer on the corner, pops them in the back of the police vehicle and takes them away, cleaning up the neighborhood. That's how our body naturally cleans up these microscopic cancers. And so when you talk about cancer as a scary disease, you're thinking about the person whose body has failed to detect and eliminate the microscopic cancers, and it's become large enough to actually become a threat. Now, here's a question for you. So we tell women to actually do a self breast exam when they're taking a shower, look for lumps or bumps. And, if you find one, certainly go to your doctor immediately for an exam. The smallest cancer that you could feel with a trained person can feel with their hands in the breast is 1 centimeter in diameter. A 1 centimeter breast cancer already has 1 billion cancer cells that have already multiplied. That microscopic cancer multiplied 1 billion times. That's the smallest one you can feel. Now, immune system's not taking them out, all right? So you need a better immune system if you want a shot at this, and not just chemo or hormonal therapy. And that's where some of these incredible advances are taking place. But there's another one. In order to feed 1 billion cancer cells, you need blood vessels to feed them. So the cancers, as they get bigger, they hijack our own circulation to feed themselves. Okay, it's kind of like terrorists kicking in the cockpit door to take over the controls of the plane. They want to actually get your blood vessels to feed themselves. Now, normally the body knows how to control those blood vessels. It's called angiogenesis, blood vessels, genesis, how the body grows and controls them. That's my area of research. So naturally, our body knows how to prevent blood vessels from feeding cancers, and yet knows how to direct blood vessels to feed healthy tissues. So guess what? A 1 centimeter tumor with 1 billion cancer cells is fed by 100 million blood vessels coursing into the tumor to feed them. And we've studied this in the laboratory. The moment that a single blood vessel touches a tumor, tiny microscopic tumor, it will grow 16,000 times in size in just 2 weeks. So with this kind of knowledge, what can we do with cancers? Not just breast cancers, but in general. Number one, we know that if you boost your immune system with foods, with exercise, diet, lifestyle, you're going to actually make your immune defenses a lot stronger to patrol your body to wipe out those microscopic cancers. That's why healthy diet and lifestyle lowers the risk of cancer. That's why eating the right foods that boost your immunity can substantially lower your risk of cancer as well. We also know that you can eat foods that support, prompt up, fortify your body's natural ability to control blood vessels. Keep those blood vessels where they're supposed to be and get rid of those blood vessels where you don't want them to be, which is kicking in the cockpit to take over your circulation to feed cancers. So if you eat foods that are anti-androgenic foods, like on Staple, you've got coffee and tea. Both of those contain natural substances that cut off the blood supply and starve cancers. That's a good thing. So that's why we know what we do with our diet can actually help to lower the risk of cancer as well. A study done by Cornell in New York, looking at Swedish women who were normal body size or skinny. So you've heard of skinny fat. This is what they were studying. And they looked at these women to see, they did DEXA scans, as you described, to see how much body fat they had. And then they followed them over 13 years. And they actually found that women who did not have extra body fat had, normal risk of breast cancer, but women who had skinny fat, remember all the women in the study, and so 3,000 women, actually were normal body size. They weren't supermodels, but they were just normal size women. Some of them were slimmer than others, but none of them were obese. None of them were overweight, just normal size. But they knew at the baseline what the DEXA scan showed. And what they found is that women who had excess body fat over the period of 13 years had a threefold increase in the risk of developing breast cancer. And it's linked to higher inflammatory markers in their bloodstream, which makes total sense. The leaking body cream, the leaking inflammation, in a skinny tube, all right, or normal size tube, normal suitcase. Look, the suitcase can't expand bigger. It's got a finite size, but it's leaking out. And this is because cancer thrives in an inflammatory environment. If you have inflammation without even a microscopic cancer, like we talked about, but a small tumor, putting inflammation in the environment of a cancer is like pouring gasoline on the embers of a fire. You ever go camping, you have a campfire, it's almost out at the very end. Now, if you pour some gasoline in it, boom, whoosh, you're going to have to create a bonfire all over again. That's how dangerous inflammation is. So that's why excess visceral fat, inflammatory fat, is so dangerous and linked to cancer. And by the way, not just breast cancer. It turns out that excess visceral fat has been linked to 14 other cancers, increased risk of 14 other cancers, everything from colon, ovarian, lung, breast, prostate. It's a growing list of cancers that seem to be you would be at a higher risk if you had high levels of visceral fat. And it makes total sense given the inflammation. Look at all these organs packed in. You got your liver, you got your stomach, you got your colon and your small intestines. That's packed into the tube. All right. It's kind of like packing for vacation. Some people are really, really skilled at packing. They can actually fold their socks and their underwear and their pants. And it's like, oh my, you're a genius. You're a packing genius, right? Now, visceral fat grows between those folded shirts and pants, and it fills a lot of space in there. When you have too much of it, not only does it fill up the suitcase of your body, the tube of your body, but it starts to push on organs, which is not healthy because it's all packing inside between the spaces, the potential spaces in there. And then when it grows beyond its own blood supply, the visceral fat starts to starve. It becomes hypoxic, meaning it's not getting enough oxygen, bigger than the amount of blood vessels that are growing in there. And now you've got the center of the fat starved of oxygen. The inflammatory cells start moving in, and now you've got this fat that's outgrown its own blood supply that's now becoming very inflammatory. And because it's packed all throughout the tube of your body, into the suitcase of your body, it's leaking out that inflammation everywhere. So think about it, like if you have a neatly packed suitcase, and you're like, I'm going to put some lotion and cream, canisters of lotion and cream. I'm going to pack it everywhere in between the spaces. Okay, look, Stephen, pack a few, but let's stop right there. And I'm going to pack like 20 or 30 of them. And you keep on stuffing it. Even though the suitcase It's a hard suitcase, and you can put a lot in there. Now you're starting to press on the clothing. You're going to scrunch up your pants, and here in the body, you're scrunching up your organs. Now, why don't we make one of those tubes of cream? Let's break one of them open. Now it's leaking. All right, and that's what's happening when your fat is so inflamed. It starts to leak inflammation. Now imagine that cream starts to leak out into the interstices of your suitcase. Now you've got a suitcase, looks skinny on the outside, looks like a suitcase. It could be a carry-on, but now all the organs, all the clothes you packed so neatly are squeezed and scrunched off, and now the lotion is leaking everywhere. That is the analogy of excess body fat in a small container, spreading out, compressing the organs, and leaking out, and that's why it's dangerous. We did research at the Androgenesis Foundation, the nonprofit I looked at, to look at different types of teas, different types of green tea, Japanese tea, Chinese jasmine tea, English tea. And we were always assuming, again, this is the power of food as medicine research, we were always assuming that the green tea is going to be the best. I'd always heard that Japanese green tea is going to be like the ultra best. And what we found was that English tea, specifically Earl Grey tea, actually was the most potent when it actually supported your blood vessels, your body's defense system for angiogenesis to keep your circulation healthy. Wow, what a surprise that is. And this spoke to me about the fact that we can't make assumptions. We need to look at facts. We need to look at data. And so I'm a big fan of Earl Grey now. Now, what might make give Earl Grey its superpower? Well, this is where knowing a little bit about what you're eating is actually useful, because Earl Grey is a fermented, it's a black tea. It's got bergamot in it, and bergamot is a kind of a citrus. So maybe it's combining those ingredients that actually provides the superpower. But I do see matcha on this tray. I want to tell you about matcha, because matcha is truly a super enriched, polyphenol enriched tea. A lot of people don't realize it. There's no tea bag in it, so don't worry. Yeah. So a lot of people think about matcha as just another green tea, but it's not another green tea. It is made with green tea leaves, the same kind of green tea leaves, but as you would find in any green tea. However, what's the composition of matcha? Matcha is green tea that is, before it's ready for harvest, is grown under a shade that changes its chemical structure, natural chemical structure a little bit. So it's got a lot of potency to it. And what happens with matcha is they take the tea leaf, they take out the stem of the green tea leaf, and they ground up the actual leaf into a powder. Now, what's in that green tea leaf? You've got not just some of the polyphenols that might steep out in the cup, whether you're using a tea bag or loose leaf tea, you're getting all the polyphenols suspended in that. So now you get 100% polyphenol, okay, in matcha. So go ahead, do it. Okay, that one's good. All right. Okay, for matcha. And because you're getting the tea leaf ground to it, you're also getting your dietary fiber. The dietary fiber is good for your gut health, your microbiome, good for your metabolism, good for lowering inflammation. And the polyphenols found in green tea have also been, matcha tea, have also been found in the lab to kill breast cancer stem cells. What's a breast cancer stem cell? What's a cancer stem cell? Well, look, stem cells are these renewable cells, all right? And cancers contain stem cells that help the cancers come back, right? If you got cancer, you get it treated. The one thing you don't want it to do is to come back. So, and by the way, other foods can also kill cancer stem cells. Purple potatoes that you might have seen in the market, they're kind of purpley looking on the outside. Slice it open, dark purple on the inside. All right. Turns out that those purple potatoes have something called anthocyanins. Purple potatoes have been studied in a lab, okay, at Penn State University, and been shown to kill colon cancer stem cells, which contribute to the colon cancer coming back. So angiogenesis is how our body grows and maintains our circulation. A lot of people don't know this, but our circulation is one of our body's health defense systems, and it's so extensive that in a typical adult, there are 60,000 miles worth of blood vessels packed inside our body. These are the highways and byways that deliver blood to every organ and tissue. But that means that they also deliver the air we breathe, the oxygen we're breathing in, and the nutrients that we're eating. So we eat good things, they're going into our bloodstream, and our blood vessels, our angiogenesis system is delivering to every cell in the body. Now, you eat something bad, similarly, or you breathe something in bad, similarly, those blood vessels are delivering something negative. Now, inside the blood vessels is a lining. It's called the lining is like a clear, like a plastic wrap inside the blood vessel called the endothelial layer. That's like a layer of ice, like on an ice skating rink, to ensure that everything in the blood vessels are flowing smoothly without getting caught on the walls. So when you have cardiovascular disease, too much salt, hypertension, when you have diabetes, where you're actually wearing down the lining of the blood vessels, endothelial layers being damaged, it's like damaging the lining of your angiogenesis defense system has really deadly consequences because it's like scraping up the ice on an ice skating rink. If you actually have a lot of ice skaters on a rink, after a while, it's unskateable, right? You can't get on it. And what will happen in your bloodstream is then elements in your blood get caught along the walls and they build up. And that's actually how blood vessels narrow up. So that's one of the areas so angiogenesis actually is intended to deliver oxygen and nutrients to the tissues that need it to maintain your health. But because it's so critical, it's also very, very carefully controlled. So you don't have blood vessels growing where they should not be growing, like in your joints, in your eyes, or of course to cancers. You definitely don't want to be feeding cancers by delivering oxygen or nutrients to them. If you took a tumor and sequenced all the genes, you find every mutation, every typographical error that we talked about earlier that's in that cancer. Those are the smoking guns of the cancer. Now, what if I took a piece of a little normal blood, normal cells, and sequenced that too? All right. Now, people are hearing me talk who are oncologists or scientists would say, I don't know what you're talking about. That's like double the waste of effort because now you're going to sequence the human genome twice in a single patient. What are you going to do with all that information? This is where technology sits in. Artificial intelligence, machine learning. Let's now have a computer compare normal cells with tumor cells, back and forth and back and forth and back and forth, subtract out all the mutations that are found in normal cells, leaving only the smoking gun mutations in the cancer. A couple hundred are going to be left. Those are the smoking guns. Those are the doers that led to this cancer. Now imagine, and I'm going to give you an analogy here. Do you remember that Tom Cruise movie, Minority Report?
Yeah.
So you remember like he was wearing these gloves and you have a glass pane and you can actually move the things around on the glass with your fingertips, right? So now imagine you can take these human, the cancer mutations on the bottom of this glass screen and you can just randomly with your fingers pick out 20 random mutations and move them up on the screen. All right, now you've just picked out the mutations, and now you can connect the mutations together. I call it a pearl necklace. Imagine every mutation's a pearl, and you connect them together with the string that connects the pearl necklace. Now you get what I'm saying? Like now we've taken the tumor, find out the doers, the smoking guns. Now we've strung them together. Okay, this is the most wanted sign that you would actually place out for the criminal. And now imagine you hit print technology. And now you have a protein printer that prints out those smoking guns as a protein full of your own individual cancer of that particular person. Now you take that protein and you inject it under the skin and you're challenging your own immune system. You're vaccinating yourself with your own cancer and you're causing your own immune system to say, aha, this is a bad guy. We're going to develop antibodies to go find our immune system. We're going to get ratcheted up to go find that cancer. Well, this is happening right now in clinical trials. I have a colleague named Saskia Biskup that is actually developing peptide vaccine treatments against cancer. And if you want to see some amazing results, there was a paper we published in Nature Communications about a year ago that showed in more than 100 people with glioblastoma, that is a game over brain cancer. Nobody lives more than a couple of years with this, all right? That with this treatment, we've been able to actually show that some patients with their own immune system woken up can actually keep them alive and cancer-free. Brain cancer, like that is no-win situation, impossible to possible. Hey, if you like that video, then you're going to love this one. Check it out.